At first, the reports seemed scattered. A drone lost here, another one missing a few days later, then another. Individually, each incident looked small. Military aircraft are lost in conflicts from time to time, and a single unmanned aircraft rarely makes global headlines. But when analysts began putting the pieces together, a pattern slowly appeared. Several MQ-9 Reaper drones, operated by the United States, had been shot down or destroyed during the conflict with Iran. And suddenly, those scattered incidents started to tell a much larger story. The MQ-9 Reaper is not just another drone. It is one of the most important unmanned aircraft in the U.S. military. The drone is used for surveillance, reconnaissance, and precision strikes. It can remain airborne for more than 20 hours, watching large areas of territory from high altitude while transmitting live intelligence to commanders. In many conflicts, aircraft like the Reaper act as the eyes in the sky. They monitor troop movements. They track vehicles. They identify potential threats before pilots or soldiers ever encounter them. And when necessary, they can also carry guided weapons capable of striking specific targets with remarkable precision. Because of that versatility, the MQ-9 has become a central platform in modern American military operations, which is exactly why the recent losses drew so much attention. According to open-source tracking and conflict reports, multiple MQ-9 Reaper drones were shot down by Iranian air defenses during the conflict. Some were reportedly intercepted by surface-to-air missiles. Others were lost during operational incidents connected to combat activity. In total, reports suggest that around 9 MQ-9 drones were shot down, while additional aircraft were destroyed or lost during related operations. One drone was reportedly destroyed by a missile strike while still on the ground. 2 others were lost in accidents during operational missions. Individually, these incidents may appear limited, but when viewed together, they reveal something important. Iran's air defense network has demonstrated the ability to challenge some of the most widely used unmanned surveillance aircraft in the U.S. arsenal. Now here's something worth understanding. The MQ-9 Reaper was designed to operate in environments where the enemy's air defenses are limited. It flies high above the ground, often above 40,000 feet. From that altitude, it can observe large areas while remaining out of reach of many short-range weapons. But that altitude does not make the drone invulnerable. Modern surface-to-air missile systems are capable of reaching aircraft flying far above the ground. And when those systems are combined with radar networks that detect incoming aircraft, even unmanned platforms can become targets. In several reported incidents, Iranian air defense units detected MQ-9 drones operating in contested airspace and launched missiles to intercept them. Once a missile locks onto a target, the drone has limited options to escape. Unlike fighter jets, unmanned aircraft cannot perform aggressive, evasive maneuvers at high speed. They are slower. They rely more heavily on altitude and distance for protection. And when a missile reaches them, the result is often final. Fragments of wreckage fall back toward the ground. The surveillance feed disappears, and the aircraft becomes another entry on the growing list of equipment lost in the conflict. Now here is the strategic part that analysts focus on. The loss of drones does not necessarily change the outcome of a war, but it does affect how information flows across the battlefield. Reaper drones provide commanders with real-time intelligence. They allow forces to observe activity in areas where manned aircraft might face greater risk. They track targets for hours or even days. Remove those eyes from the sky, even temporarily, and commanders must rely on other sources of information. Satellites, ground reports, other aircraft. Each alternative has its own limitations, which is why drones like the MQ-9 became so important in the first place. Now consider the financial dimension as well. A single MQ-9 Reaper costs tens of millions of dollars when the full system is considered, including sensors, communication equipment, and ground control stations. But the cost alone does not capture the entire value of the platform. The real value lies in the information it gathers, the hours of surveillance, the intelligence it provides to commanders making decisions in real time. When one of those drones is lost, the loss is not only measured in equipment, it is measured in visibility, in awareness, in the ability to see what is happening across the battlefield. Now step back and look at the broader pattern emerging from these incidents. The increasing number of drone losses suggests that air defense systems are adapting to the growing presence of unmanned aircraft. For years, drones operated with relatively little resistance in many regions. But that environment is changing. Countries are investing more heavily in radar networks designed to detect smaller aerial targets. Surface-to-air missile systems are being modernized. Electronic warfare tools are being deployed to disrupt drone communication links. Together, these systems create a more contested airspace, one where unmanned aircraft must operate more carefully, and one where losses become more likely. The MQ-9 incidents highlight that shift clearly. They show that even advanced unmanned systems cannot always operate freely when facing modern air defenses. And they demonstrate how the technological competition between drones and air defense systems continues to evolve. But the story behind these losses goes deeper than the number of drones shot down, because each interception represents a moment when technology, strategy, and battlefield conditions intersect. A radar detection, a missile launch, a target destroyed high above the ground. And every one of those moments sends a message. A message about the changing balance between surveillance technology and the systems designed to stop it. At first glance, losing drones may not seem as dramatic as losing fighter jets or bombers. After all, drones are unmanned. No pilot is sitting in the cockpit. No rescue mission is required if the aircraft is destroyed. But that does not mean the loss is insignificant. In fact, when multiple surveillance drones are shot down within a short period of time, analysts begin paying very close attention, because those aircraft play a crucial role in modern military operations. To understand why, you need to look at how the MQ-9 Reaper is actually used during a conflict. The aircraft is not just a flying camera. It is a surveillance platform designed to stay in the air for extremely long periods of time. A single Reaper drone can remain airborne for more than 20 hours. That means it can watch a road, a border region, or a military facility continuously throughout an entire day. It can follow vehicles moving across large distances. It can monitor air defense sites. It can observe troop movements. And it can send all of that information back to commanders in real time. That continuous stream of intelligence is incredibly valuable, because on a modern battlefield, information often matters just as much as firepower. Knowing where forces are moving, knowing which radar systems are active, knowing when equipment is being relocated. All of these details help commanders make decisions about when and where to act. Without that information, operations become far more uncertain. And that is why losing surveillance drones can have wider implications. Every drone that disappears from the sky reduces the amount of real-time intelligence available to planners. Now consider another factor. Unlike many other military aircraft, the MQ-9 is designed to fly slowly. Its cruising speed is far lower than that of a fighter jet. This design allows the aircraft to remain stable while collecting high-resolution imagery and tracking targets on the ground. But that slower speed also creates a vulnerability. When a missile is launched toward a high-speed jet, the pilot can attempt evasive maneuvers, sharp turns, rapid altitude changes, high-speed acceleration. These actions do not guarantee survival, but they can increase the chances of escaping an incoming missile. A drone does not have that advantage. It cannot perform aggressive maneuvers at high speed. It cannot accelerate rapidly, and it does not have a pilot making split-second decisions inside the cockpit. Instead, the aircraft relies largely on altitude and distance for protection. When operating over regions with limited air defenses, that strategy works well. But in areas protected by modern radar systems and long-range surface-to-air missiles, the situation changes. Once the drone is detected, the missile has a relatively predictable target to pursue, and when that missile reaches the aircraft, the outcome is usually decisive. The drone is destroyed, fragments fall back toward the ground, and the surveillance feed disappears from the control station. That moment, when the video signal cuts out, is often the first confirmation that the aircraft has been lost. Now think about what happens next. The loss of a drone triggers a chain of responses. Military analysts review the last recorded flight path. They examine radar data. They analyze the signals transmitted by the aircraft before it disappeared. The goal is to determine exactly how the interception occurred. Was the drone detected earlier than expected? Did the air defense radar lock on from an unusual angle? Did electronic warfare systems interfere with the drone's communication link? Every piece of information helps planners adjust how future missions are conducted. Sometimes that means flying at different altitudes. Sometimes it means changing flight routes. Sometimes it means reducing the number of drones operating in heavily defended areas. Each adjustment is designed to reduce risk, but each adjustment also changes how intelligence is gathered. Now, there is another layer to this story that often goes unnoticed. Air defense systems are constantly evolving. Countries that expect surveillance aircraft to operate near their borders invest heavily in technologies designed to detect and intercept them. Long-range radar systems, integrated missile batteries, electronic warfare capabilities, all of these elements work together to create what military planners call layered air defense. In such an environment, aircraft are detected earlier, tracked more accurately, and engaged with greater precision. That environment makes operations more challenging not only for drones, but also for manned aircraft, which is why unmanned systems were originally seen as a safer alternative. A drone can be lost without risking a pilot's life. But even that advantage has limits, because while drones remove the human risk, they do not eliminate the operational consequences of losing surveillance capabilities. Each lost aircraft represents fewer eyes monitoring the battlefield, fewer sensors observing enemy activity, and fewer platforms available to provide real-time intelligence. That is why analysts began paying close attention when reports indicated that several MQ-9 Reapers had been shot down during the conflict. It suggested that the airspace over parts of the region had become significantly more contested. And once airspace becomes contested, every mission must be planned differently. Aircraft must operate more cautiously, routes must be carefully selected, and commanders must weigh the intelligence gained against the risk of losing valuable equipment. All of these considerations shape how military operations unfold in a contested environment. Because once surveillance becomes difficult, every decision made on the battlefield becomes more uncertain. And uncertainty is something no military commander ever wants to face. Another factor that makes these drone losses significant is the role the MQ-9 Reaper plays in modern military strategy. These aircraft are not deployed randomly. They are usually assigned to very specific missions. Some monitor border regions, others track suspected military movements. Some are tasked with watching radar installations or missile launch sites. In many cases, they remain in the same area for hours, sometimes for an entire day, quietly observing what is happening below. That persistence is what makes them so valuable. A satellite might pass over a location only a few times a day. A fighter jet can remain over a target area for a limited period before it must return to refuel. But a drone like the MQ-9 can stay there far longer, patiently gathering information and transmitting it back to operators thousands of kilometers away. Inside those control rooms, analysts watch the drone's video feed on large screens. They observe vehicles moving along roads. They track equipment being transported between facilities. They analyze patterns of activity that may reveal preparations for military operations. Sometimes the information gathered by these drones becomes the foundation for later decisions. Commanders might use it to plan surveillance missions, to determine where to deploy additional aircraft, or to understand how an adversary is positioning its forces. Without that continuous observation, those decisions become far more difficult. Now imagine what happens when several of those drones are suddenly removed from the sky. The immediate effect is a reduction in coverage. Areas that were previously monitored may temporarily disappear from the surveillance network. Analysts may lose track of activity that had been observed for days, and commanders may need to rely on alternative sources of information. Satellites might fill some of that gap. Other aircraft might be redirected. But those alternatives often come with limitations. Satellites cannot stay above the same location continuously, and manned aircraft may face greater risks in contested airspace, which is why the MQ-9 became such a central platform in the first place. It offered long endurance, high-altitude surveillance, and the ability to monitor large areas without placing pilots in danger. Yet the recent losses suggest that even these platforms are becoming vulnerable in environments where air defense systems are active. And that vulnerability has implications beyond the drones themselves. It affects how intelligence is collected, how missions are planned, and how commanders understand what is happening on the ground. Now consider the broader technological competition taking place. On one side are increasingly advanced surveillance drones equipped with powerful sensors, encrypted communication links, and sophisticated navigation systems. On the other side are evolving air defense networks designed to detect and intercept those aircraft. Radar technology improves. Missile guidance systems become more precise. Electronic warfare tools attempt to disrupt the signals that connect drones to their operators. This constant cycle of innovation creates a technological contest between surveillance and defense. Each improvement on one side leads to a countermeasure on the other. And as that competition intensifies, the skies above contested regions become more difficult for any aircraft to navigate safely. The recent reports about MQ-9 losses suggest that this contest is entering a new phase. One where surveillance drones can no longer assume uncontested access to the airspace above certain regions. Instead, every mission must be carefully evaluated. Is the intelligence worth the risk? Can the aircraft operate safely in that environment? Should additional countermeasures be deployed before sending the drone into the area? These questions become part of every operational plan. Now there is also a psychological dimension to these incidents. When a drone is shot down, the event quickly circulates through military and intelligence communities. Images of wreckage may appear online. Reports of missile interceptions may be discussed among analysts. Each incident becomes a reminder that the battlefield is constantly changing, and that even advanced technology can face unexpected challenges. This psychological effect can influence how future operations are conducted. Operators may become more cautious when flying drones near defended airspace. Commanders may choose to gather intelligence through other means before sending unmanned aircraft into certain regions. These adjustments are natural responses to evolving threats, but they also demonstrate how even limited incidents can shape the broader environment in which military operations take place. Because warfare is not only about weapons and equipment, it is also about adaptation. Every action triggers a reaction. Every new technology invites a countermeasure, and every unexpected event becomes a lesson for both sides involved in the conflict. The reports about multiple MQ-9 drones being lost during the conflict illustrate that dynamic clearly. They show how quickly the balance between surveillance and air defense can shift. And they reveal how the skies above contested regions are becoming increasingly complex and dangerous. Yet the most important question remains unanswered. What happens next if both sides continue improving their technologies? Because if surveillance drones become more advanced, air defenses will evolve to counter them. And if air defenses become stronger, new forms of unmanned aircraft will be developed to overcome those defenses. That cycle of innovation has defined military technology for generations, and it shows no sign of slowing down. Which means the story of the MQ-9 Reaper is not only about the drones that have already been lost. It is also about the future of surveillance, air defense, and the ongoing struggle for control of the skies. And that brings us to the bigger picture behind these incidents, because the story of the MQ-9 Reaper losses is not just about a handful of drones being destroyed in the sky. It is about something much larger. It is about how the nature of aerial surveillance is changing. For years, unmanned aircraft like the Reaper operated with relatively little resistance in many regions. They flew high above the ground, monitored activity for hours, and transmitted information back to operators thousands of kilometers away. Those aircraft became one of the most powerful tools in modern intelligence gathering. They allowed commanders to watch the battlefield continuously. They allowed analysts to track patterns that would otherwise remain hidden. And they allowed operations to be planned with a level of awareness that earlier generations of military forces simply did not have. But the recent losses suggest that this era of relatively uncontested drone surveillance may be coming to an end in some regions. Air defense systems are improving. Radar networks are expanding. Missile systems are becoming more precise and more capable of reaching high-altitude targets. When those systems are integrated into a layered defense network, they create an environment where even unmanned aircraft must operate with caution, and that changes the entire equation. Now, surveillance missions must be planned more carefully. Routes must avoid known radar coverage. Altitude and flight patterns must be adjusted, and commanders must decide whether the intelligence gained from a mission justifies the risk of losing another aircraft. Sometimes the answer will be yes, sometimes it will not. But the decision is no longer as simple as it once was. Now consider the broader technological competition taking place. Drones are becoming more advanced. New designs offer longer endurance, improved sensors, better communication systems. At the same time, air defense technology continues to evolve. Missiles become faster, radar becomes more sensitive, electronic warfare systems become more capable of disrupting communication links. This creates a continuous cycle. Each new surveillance technology triggers the development of a new defensive system. Each new defense system encourages the development of new aircraft designed to overcome it. And that cycle drives the evolution of modern military technology. The MQ-9 Reaper sits right in the middle of that cycle. It represents one generation of unmanned surveillance capability, a generation that proved extremely effective in many environments. But now that generation is encountering more sophisticated defenses, which raises a question that analysts are beginning to ask more frequently. What will the next generation of unmanned aircraft look like? Will they fly higher? Will they fly faster? Will they rely more on stealth or electronic countermeasures? Or will entirely new systems replace them? Those questions are already shaping research programs and military planning around the world, because the demand for persistent surveillance is not going away. Modern militaries depend on information. They depend on knowing what is happening beyond their immediate line of sight. And drones remain one of the most effective ways to gather that information. But as the recent incidents show, that capability cannot be taken for granted. Airspace that once appeared relatively open may now be contested, and every mission conducted in that environment carries new risks. Which brings us to the final point. The loss of several MQ-9 Reapers may not decide the outcome of a conflict, but it reveals something important about the direction of modern warfare. Control of the skies is no longer defined only by fighter jets and bombers. It is increasingly shaped by the interaction between surveillance systems and the defenses designed to stop them. That interaction determines who sees the battlefield first, who understands what is happening, and who must operate with uncertainty. In many ways, information has become one of the most valuable resources in modern conflict. And every drone that disappears from the sky represents a moment when that information becomes harder to obtain. Now, I want to ask you something. Do you think surveillance drones like the MQ-9 Reaper will continue to dominate modern battlefields? Or will improving air defense systems gradually push them out of contested airspace? Tell me what you think. I read every single comment. And if you want to understand what might come next in this evolving technological battle, make sure you subscribe. Because in the next video, we're going to look at something even more important. The new generation of stealth drones that military engineers are developing right now. Aircraft designed specifically to survive in the kind of defended airspace where today's drones are increasingly at risk. And trust me, the technology behind them may change the future of aerial warfare completely.